Article 400.4 states that SO cord cannot be used as fixed wiring. However, Article 400.7 allows SO cable for connecting moving parts, and Article 400.14 allows the cable to pass through a cover with a bushing. Article 400.7 does allow SO cord to be used for connecting moving parts, but it must be properly secured and protected from physical damage. In the scenario of the X-ray unit installation, the SO cord is passing through a cover with a bushing, which provides adequate protection. Article 400.4 does prohibit SO cord from being used as fixed wiring. In this case, the SO cord is not being used as fixed wiring in the traditional sense of power distribution. Instead, it is being used as part of the X-ray unit circuitry to connect a moving part. Based on the exception in Article 400.7, the use of SO cable is permitted for this application. Attaching plugs to the SO cords and terminating the THHN on receptacles is not necessary and may not be appropriate for the manufacturer's equipment design. It is important to understand the specific requirements and exceptions outlined in Article 400 of the National Electrical Code, or NEC, concerning the use of flexible cords and cables. Article 400.4 specifically addresses the uses that are not permitted for flexible cords and cables, which includes using them as a substitute for the fixed wiring of a structure, running them through holes in walls, ceilings, or floors, running them through doorways, windows, or similar openings, or attaching them to building surfaces. The key here is that flexible cords are generally not intended to replace permanent wiring methods. However, Article 400.7 outlines situations where the use of flexible cords and cables is indeed permitted. These permitted uses often involve specific applications where flexibility and movement are necessary, or where temporary connections are required. A crucial exception is found in Article 400.7, which allows the use of flexible cords for connecting portable equipment or appliances. This is particularly relevant when the equipment needs to be easily moved or repositioned. In these cases, the flexible cord provides the necessary flexibility without compromising safety. In the situation described, the X-ray unit has a moving part with two SO cables extending from it. The fact that these cables are part of a moving component is significant because it directly relates to the exception in Article 400.7. This section recognizes that flexible cords are often necessary to accommodate movement in equipment. The installation involves running these SO cables through a hole in a cover plate on a wall box and then splicing them to THHN wire, which runs in conduit to the X-ray unit. The local electrical inspector has raised concerns, stating that SO cord cannot be used as a substitute for fixed wiring and suggesting the installation of attachment plugs on the SO cords with corresponding receptacles for the THHN wire. This raises the question of whether the existing installation complies with the NEC or if the inspector's proposed changes are necessary. Article 400.14 addresses the protection of flexible cords and cables where they pass through surfaces. It specifically states that flexible cords and cables must be protected from abrasion and physical damage where they pass through holes in covers, outlet boxes, or similar enclosures. This protection is typically achieved by using bushings or fittings designed to prevent the cord from being damaged by sharp edges. In this installation, the SO cord passes through a hole in a cover plate on a wall box. The presence of a bushing, as mentioned, is crucial because it ensures that the cord is protected from physical damage as it passes through the metal cover plate. Without a bushing, the sharp edge of the hole could potentially damage the cord's insulation, creating a safety hazard. Therefore, the use of a bushing is a code-compliant method of protecting the flexible cord in this situation. The inspector's concern about using SO cord as fixed wiring is rooted in the general prohibition outlined in Article 400.4. However, it's essential to consider the specific context of the installation. In this case, the SO cord is not being used as a substitute for the building's fixed wiring system. Instead, it is an integral part of the X-ray unit's internal circuitry, connecting a moving component to the rest of the equipment. This distinction is important because the SO cord is serving a different purpose than typical building wiring. It is facilitating the necessary movement of the X-ray unit's components, which is a permitted use under Article 400.7. The inspector's suggestion to add plugs and receptacles to the SO cords raises a few concerns. Firstly, it involves modifying the manufacturer's equipment design. Electrical equipment, such as X-ray units, is typically designed and tested as a complete system. Altering the wiring configuration by adding plugs and receptacles could potentially void the equipment's warranty or compromise its safety certifications. Secondly, adding plugs and receptacles introduces additional connection points, which could be potential sources of failure or loose connections. These connections would need to be properly maintained and inspected to ensure they remain secure and reliable. Furthermore, the use of non-standard receptacles, as mentioned, could create confusion or safety hazards if someone attempts to plug in other equipment that is not compatible with the X-ray unit's circuitry. Given the specific circumstances of this installation, it appears that the use of SO cord is permitted under the exception in Article 400.78, as long as the cord is properly protected from physical damage, as described in Article 400.14. The SO cord is not being used as a substitute for fixed wiring, but rather as a necessary component for connecting a moving part within the X-ray unit. Therefore, the inspector's requirement to add plugs and receptacles may not be necessary or appropriate. However, electrical inspections and code interpretations can sometimes be subjective, and local jurisdictions may have their own specific requirements or interpretations. In situations where there is a disagreement with the electrical inspector, it's often helpful to engage in open communication and provide documentation to support the code compliance of the installation. If the disagreement persists, the next step would be to contact the authority having jurisdiction, or OJ, which is the local electrical code enforcement agency. The AHA has the final authority to interpret and enforce the electrical code in its jurisdiction. Seeking clarification or a formal ruling from the AHA can help resolve the dispute and ensure that the installation meets all applicable requirements. When contacting the AHA, it's important to present all relevant information, including the equipment specifications, the wiring diagram, and the specific code articles that support the installation's compliance. A clear and concise explanation of the situation can help the AHA understand the context and make an informed decision. In some cases, the AHA may request additional information or documentation to further evaluate the installation. The goal is to reach a mutually agreeable solution that ensures the safety and code compliance of the electrical system. Flexible cords and cables must be suitable for the conditions of use and the type of equipment they serve. Factors to consider include the cord's opacity, voltage rating, and environmental rating. The cord must be properly sized to handle the electrical load of the equipment without overheating or creating a fire hazard. The cord's insulation must be suitable for the operating temperature and environmental conditions of the location. For example, cords used in damp or wet locations must be rated for wet locations. Flexible cords and cables must be protected from physical damage such as abrasion, cuts, and impact. This protection can be provided by using cord protectors, strain relief devices, or other suitable means. The cord must be supported to prevent strain on the connections and to ensure that it does not come into contact with sharp edges or other objects that could damage it. Flexible cords and cables must be properly connected to the equipment and the power source. The connections must be made using approved methods such as cord connectors, attachment plugs, or terminal blocks. The connections must be secure and tight to prevent loose connections which can cause overheating or arcing. Flexible cords and cables must not be used in a manner that creates a safety hazard. For example, they must not be run through doorways or windows where they could be pinched or damaged. They must not be used to support equipment or to suspend objects from the ceiling. And they must not be used in areas where they could be exposed to flammable liquids or gases. Firstly, review the relevant sections of the National Electrical Code, or NEC, specifically Article 400, which covers flexible cords and cables. Pay close attention to the permitted and prohibited uses of flexible cords, as well as the requirements for their installation and protection. Secondly, gather all relevant documentation related to the X-ray unit, including the manufacturer's specifications, wiring diagrams, and any safety certifications. This information will help demonstrate that the equipment is designed to use SO code for connecting moving parts. Thirdly, prepare a clear and concise explanation of the installation, highlighting the fact that the SO code is not being used as a substitute for fixed wiring but rather as an integral part of the X-ray unit circuitry. Emphasize that the cord is properly protected by a bushing where it passes through the cover plate. Fourthly, contact the local electrical inspector or the authority having jurisdiction, or OJ, to discuss the installation and present your case. Be prepared to answer any questions they may have and to provide supporting documentation. Fifthly, if the inspector remains unconvinced, request a formal interpretation of the code from the AHA. This will provide a written ruling that can be used to resolve the dispute. Consider these additional points. It's important to ensure that the SO code is of the appropriate size and type for the application. The code's ampacity, voltage rating, and environmental rating should be suitable for the X-ray unit's electrical requirements and the conditions of use. Make sure that the SO code is properly secured and supported to prevent strain on the connections. Use strain relief devices or other appropriate methods to ensure that the cord is not pulled or stretched excessively. Verify that all connections are made using approved methods such as cord connectors or terminal blocks. The connections should be secure and tight to prevent loose connections, which can cause overheating or arcing. Ensure that the SO cord is protected from physical damage such as abrasion, cuts, and impact. Use cord protectors or other means to prevent the cord from being damaged. Make sure that the installation complies with all other applicable requirements of the NEC and any local codes or regulations. Consult with a qualified electrician or electrical engineer if you have any questions or concerns about the installation. The argument centers around whether the use of SO code in this specific application is permissible under the National Electrical Code, or NEC. The inspector believes that the SO code is being used as a substitute for fixed wiring, which is generally prohibited by Article 400.4. Your argument, however, relies on the exception provided in Article 400.78, which allows the use of flexible codes for connecting moving parts. The key to resolving this dispute lies in understanding the intent and scope of these code articles. Article 400.4 is intended to prevent the misuse of flexible cords as a replacement for permanent building wiring. Flexible cords are not designed to withstand the same stresses and environmental conditions as fixed wiring methods such as conduit and THHM wire. Using flexible cords as fixed wiring can create a safety hazard due to the potential for damage, overheating, and electrical shock. Article 400.7, on the other hand, recognizes that there are certain situations where the use of flexible cords is necessary or advantageous. One such situation is the connection of moving parts and equipment. In these cases, a flexible cord is required to allow for the movement without putting undue strain on the wiring connections. The X-ray unit in question falls under this exception because the SO cord is being used to connect a moving part within the equipment. The cord is not being used as a substitute for the building's wiring system, but rather as an integral component of the X-ray unit's internal circuitry. The fact that the SO cord passes through a cover with a bushing further supports the argument that the installation is code compliant. Article 400.14 requires that flexible cords be protected from abrasion and physical damage where they pass through holes in covers or similar enclosures. The bushing provides this protection, ensuring that the cord's insulation is not damaged by sharp edges. The inspector's suggestion to add plugs and receptacles to the SO cords raises additional concerns. Firstly, it involves modifying the manufacturer's equipment design, which could potentially void the equipment's warranty or compromise its safety certifications. Secondly, it introduces additional connection points, which could be potential sources of failure or loose connections. The best course of action is to engage in a constructive dialogue with the electrical inspector. Explain your understanding of the code and the specific circumstances of the installation. Provide documentation to support your argument, such as the X-ray unit specifications and wiring diagrams. If the inspector remains unconvinced, request a formal interpretation of the code from the authority having jurisdiction, or OJ. The AHA is the final authority on code interpretations and can provide a written ruling that will resolve the dispute. When presenting your case to the inspector or the AHJ, it's important to be respectful and professional. Clearly explain your reasoning and be prepared to answer any questions they may have. Remember that the goal is to ensure the safety and code compliance of the installation, and a collaborative approach is often the most effective way to achieve this.